Good morning, everyone. Thank you so much, Dan. And I'd like to thank Ellen Woods and Phelps for inviting me here today. Flooding is also part of my portfolio. If you like this lecture, maybe I could do another one on flooding and we could discuss options for the Sawmill River Parkway then. All right. From the Nile in ancient Egypt to our highway systems today, transportation is one of the most important factors shaping the way people live. Today, we are going to talk about what may be the single transportation project with the largest influence in our region during our lifetimes, the Tappan Zee Bridge. I'll start with some brief background about how our communities grew with our transportation. As our transportation got more efficient, our population rose. I'll then place the bridge in the context of the growth of our road infrastructure, the building of our Hudson River crossings, and the start of our state thruway and interstate highway system. Then we'll talk a little about the engineering of the bridge and view some archival photos of the construction. After looking at the impacts of the bridge on our region, some good, some not so good, we'll discuss the plans for the new bridge and for a new mass transit system centered on it. Okay. In colonial times, man-made development in our region was primarily comprised of farms. Does anyone recognize the photo on the left? Yeah, that's right. It's Phillipsburg Manor just down the road here on Route 9. That was established in 1693. On the right is the Sailor House, a Dutch colonial farmhouse in Pearl River, Rockland County. It was built in the late 1700s and now houses part of the Orangetown Historical Museum. Except for some small commercial centers, there wasn't much else in Westchester or Rockland back then. The main forms of transportation were sailboats and horses, so the area remained predominantly rural. But that changed in the decades after 1800, when we see the beginnings of suburbanization. Washington Irving began converting an old farmhouse into his dream suburban home, Sunnyside, in 1835. A lot of you have been to Sunnyside? It's a beautiful place. They also have a good jazz festival in September. While the suburban ideals of combining modern comforts with carefully crafted reminders of nature were pretty much in place already back then, the form of transport confined suburbia to a small number of extremely wealthy people. Does anyone know the primary form of transportation to our Hudson Valley suburbs back then? We did a lot of horse and carriage. Steamboat. Remember, the steamboat was invented the first decade of the 1800s, and that was how most people made it up to the growing community of large houses in, say, Tarrytown from Manhattan. They went up the Hudson by steamboat. We did have toll roads, especially in the eastern part of the county, but given what the quality of those roads were like and the fact that your speed was very much confined to how fast a horse can pull a cart or a carriage, steamboat was the better bet. But again, it limited the market for housing up here to fairly affluent people. In the century from 1850 to 1950, though, two forms of transportation, in their turn, came to dominate our county. First the railroad, and then the automobile. The concept of the bedroom community, whose primary purpose was to provide housing for people who worked in the city, was made possible with the advent of the railroad. The three main commuter lines that we still use today that go into Grand Central, the Hudson, the Harlem, and the New Haven line, were largely in place by 1850. The New York and Harlem line was completed as far as White Plains in 1844 and then extended to Albany in 1850. The New York and New Haven line was completed in 1849 and the Hudson line was completed to Peekskill by 1849. In the early 1900s, the growing popularity of the automobile led to the development of the Parkway, the first form of the limited access highway. Limited access highway is the technical name for highways with exits. So that way you're not stopping to accommodate traffic every city block. You go a long distance before you merge with other people. That's supposed to increase the speed and the efficiency of travel. The first parkway in this entire country was the Bronx River Parkway, shown up here, which was completed in 1925. Now, let me show you something on here which I found really interesting. This, of course, is a more recent picture of the parkway. Look at the cars. This was obviously taken shortly after it was opened in 1925. But you notice something about the road? No lines. No lines. It was a free-for-all out there. Fortunately, people were not trying to go on it at 70 miles an hour the way they do today. Now, after the Bronx River Parkway, the Sawmill River Parkway was begun right after in 1926 and reached Chappaqua by 1940, but it was not completed until 1955 because of the war. The Hutchinson River Parkway was started in 1924 and completed in 1941. Next slide. Modes of transportation which brought the advantages of suburbia to more people helped grow the population of Westchester County. Between 1850 and 1860, the population of Westchester increased from 58,263 in 1850 to 99,497 in 1860. That was roughly a 70% increase. The population shot up again in the 1920s, which was the same decade as the start of the Parkway system. The population in Westchester rose by 51% from 1920 to 1930. Growing from 344,000 to 520,000. That rate of increase isn't as high as that of the decade after the start of the railroads, but there are problems of measuring population around the time of the completion of the Bronx River Parkway. Remember, up here with the railroads, we're able to measure a full decade with census figures after the railroads are open. Here, the Bronx River Parkway, the first parkway, wasn't open until the middle of the decade, so you're only going to see so much of an increase. You're not likely to see as much as if you had a full decade. But we couldn't use the figures from the 1930s. Can anyone guess why? We all know that the Depression happened in the 1930s, and the Depression slowed down marriage rates, it slowed down birth rates. So we're not going to get a really accurate read because the population stagnated so much at that point. But from what we can tell from the figures between 1920 and 1930, the highways certainly were part of a large population boom in this county. During the century from 1850 to 1950 as well, Westchester's cities grew, especially along the southern border with the Bronx, and heavy industry grew where the transportation was. One example is shown right here. Hastings-on-Hudson's Anaconda Wire and Cable Company, as well as dozens of other plants in Westchester's river communities, depended not just on the river, but they depended on the railroads too. And in fact, you can see back behind here the train tracks and the train station. All right, next slide. By contrast, Rockland County did develop some industry. Nyack was actually known as Shoe Town for much of the 1800s because they made shoes. But they did develop towns and industries, but not to the same degree as Westchester. Rockland kept more of its rural character, and in many places still has more of a rural character. Conklin Farm in Pomona, which is right up here, was established in 1711. And as you can see, it still retains a fairly highly rural character even today. Now, why was Westchester more highly developed than Rockland? Exactly. The main reason was the lack of direct land transit to New York City. And there was, with the lack of land transit, you could only move so many people so quickly, so you were not going to get the growth of bedroom communities like you had in Westchester. I really like this slide because this shows us the Hudson at the Tappan Zee, and it shows what was going on in the river during the 1700s and much of the 1800s as well. There was a fairly strong trade between the village of Tarrytown and the village of Nyack, even in the 1700s. But the main conveyance for that trade was the sailboat, which, number one, explains why Nyack was able to develop as much as it did, but it also shows us how Nyack and the rest of Rockland was limited because they did not have fast, efficient transportation. Okay. But that was about to change. While our parkways were being built in Westchester, a number of Hudson River crossings, bridges and tunnels, were also being built for cars. The George Washington Bridge, which is depicted in this slide, was completed in 1931. Before that, in 1924, the Bear Mountain Bridge was completed. But those of you who are familiar with Bear Mountain know that its potential is somewhat limited. It has only 2 lanes, and on either side, the road system is fairly limited as well, so it can only handle a small volume of traffic. The Holland Tunnel, however, did open in 1927. The first tube of the Lincoln Tunnel was completed in 1937, and the second tube in 1945. Now, a southern Westchester crossing was also discussed at that time. There was thought of a bridge linking the village of Hastings. These are the Palisades across from Hastings. I thought we'd all appreciate that picture today. Hopefully we will get snow again, folks. They were thinking about Hastings. They were thinking about Dobbs Ferry. There was also talk about Irvington as the eastern landfall for a Hudson crossing from Westchester to either Rockland or the northern tip of New Jersey just south of it. But instead, the location for the bridge became the Tappan Zee. It was a challenging spot because the Hudson is almost 3 miles wide there. It's the second widest point along the entire river, and it's much, much wider than the length of most bridges. That length presents engineering challenges, not to mention financial challenges, because the longer the bridge, the more materials you need and the more money you have to spend. So why here? And why do I have a picture of Governor Dewey up there? The answer begins with the impetus for this particular Westchester crossing. There were a number of bridges contemplated throughout that generation spanning World War II, the years before and the years after. But the one that was actually built, which was the Tappan Zee, was conceived as part of the New York State Thruway system, which was begun under Governor Dewey. The growth of the automobile and the dramatic rise in population in the 20th century required roadways bigger than the Bronx River Parkway, roadways that could carry many, many cars, that could hold big trucks, which were carrying more and more of our freight as highways grew in importance and most railroad lines began to atrophy. Roadways that would also open Rockland County for suburban development during the post-World War II housing shortage. The Thruway, in turn, was going to become eventually a vital link in the interstate highway system, from upstate New York to the New York City metropolitan area and to New Jersey and New England and beyond. The primary argument for the interstate system, I'm sure many of you know, was not suburbanization, but national security and emergency response. If you had to evacuate New York City, you needed a bigger crossing across the Hudson. If you needed to evacuate Westchester, if you needed to evacuate people from the Western Shore to Westchester, you needed a big bridge to do it. And by the way, these same arguments, these emergency response and these national security arguments, were not just made by President Eisenhower and the federal government for the interstate highway system, which came into being a couple years after the Tappan Zee and most of the Thruway, but they were also made by Dewey for the New York State Thruway to refute the last opponents to the road system. So why was the bridge here? The Tappan Zee Bridge, as we said, was planned as a New York State Thruway bridge and was going to be paid for by the Thruway Authority, with tolls collected from the folks who drove over the bridge. A Hastings or Dobbs Ferry or Irvington crossing, all of which were considered earlier, would have presented a financial problem for the Thruway Authority, because that part of the Hudson River was under the jurisdiction of the Port Authority of New York and New Jersey. And the original Port Authority agreement between the two states barred toll crossings competing with the George Washington Bridge, which was under the Port Authority's purview. The Tappan Zee was slightly north of the border between the Thruway authorities and the Port Authority's jurisdiction. So the Tappan Zee it was. Now, although it made sense from a legal perspective, the location presented engineering challenges even beyond the sheer length of the expanse to be crossed. The Tappan Zee's geology presented serious construction issues. The main river channels in the center of the riverbed were cut very deep from hundreds of millions of years of erosion and glaciers. And then that big chasm was filled with silt. Silt of different texture and made out of different rock, depending on where in the channel you were and how far down into the riverbed you went. And this silt in some places was hundreds of feet deep. Now, how to keep the center of that bridge stable when bedrock is so far below the surface was a real challenge. The solution is something called the floating caisson. There were 8 floating caissons anchored by pilings which bridged the deepest part of the channel crossing. The word caisson is a fancy name for a big box. Floating caissons, gigantic hollow concrete boxes, were used to build temporary bridges in World War II. In fact, I have to tell you a little story. Generally, when I write presentations or speeches or articles at night, I keep the TV on in the background for background noise. And I had it on while I was typing up this presentation. And at one point, I looked up and I said, "That's a floating caisson on my TV screen." Turned out I had the History Channel on. And there was a show about the Allied landings in Northern Europe. And floating caissons were used to build temporary bridges to bring the vehicles and the troops from harbors onto dry land. And part of the way they were able to build those temporary bridges at the strength they needed, but quickly and cheaply, was the floating caisson. The caissons for the Tappan Zee were particularly large. If you look at those old History Channel shows, you see those those bridges are usually 1 lane, maybe 2 lanes wide. Of course, the Tappan Zee is a much wider bridge than that. So the caissons at their largest are 100 feet long by 190 feet wide and 40 feet deep. We're talking about a concrete box that's pretty good, would be a pretty good size for a big box store today. The concrete itself was 28 inches thick on the bottom and up to 56 inches thick along the walls. It thickened as you made it to the bottom. The caissons were filled with water and settled into the riverbed. They were designed to hold 70% of what's called the dead weight of the bridge. So they were sunk, they were filled with water and they were sunk. Then as the bridge was constructed and the weight started to pile on the caissons, the water was gradually pumped out. And they were eventually sealed on top and were made watertight. That doesn't mean completely watertight, but it means people can control the amount of water in them. Given that the riverbed was not stable, actually, these are still floating caissons in a way because they may not be floating directly in the water, but they're floating in a sea of silt and sediment, which doesn't stay completely stable. But because they're floating, you need to make them more stable if you're going to have a permanent structure. So the way they did that was they sunk rods through the bottom of the caissons. Some of these rods are 295 feet long. They're sealed with a special, I hesitate to use the word caulk because obviously it's not the stuff you put in your bathroom, but there is a form of special cement designed by the engineers which serves as caulking around these rods. And these rods would sink, would give you these caissons support all the way down through the silt to a more gravelly bed, which provided more security for the structure. Given the length of the bridge and the differing composition of the riverbed, and given the difference in geology between the east and west landfall, you had bedrock on the west side, which was sedimentary rock, and you had a harder metamorphic rock on the east side. The bridge is a composite of different bridge types. Originally, the plan was for a tied, what's called a tied arch bridge in the middle. And that project was actually put out to bid. But there were no bids from the steel erecting and fabricating companies because no one was able to build that type of bridge within the budget presented by the Thruway Authority. So instead, the center of the bridge, the main span, is comprised of 2 cantilevered sections. For those of you who don't know, a cantilevered bridge is supported with sections that jut out from a stable support. So they're not supported underneath, but the load gets sent to the side into supports. So the cantilevers are here. They're joined in the middle by a suspended section that's like the last piece in the puzzle. There are actually pictures of it being dropped in the center. And then there's a 640-foot center truss on either side. Trusses refer to these networks of triangles made out of metal that rise above the road surface. I don't know enough about civil engineering to explain all of it to you, but essentially these are all ways of distributing the stresses of the weight of the bridge and of gravity so that the thing remains standing. Now these sections in here, your center trusses, your cantilevers, and your center section are known as the main span. They're higher than the rest of the bridge. They're 138 feet off the water, so that way big ships that come up the Hudson can fit underneath. Now, in between the main span and the river banks are east and west deck trusses, and an east trestle by the tolls, and an approximately 8,000-foot-long causeway that leads from the main part of the bridge down into Rockland County. Now, here's some math for those of you who are interested. The bridge total length is 16,013 feet, which is a little less than 3¼ miles. The main span, all those pieces, the 5 pieces I told you about, is 1,202 feet. The center span is 531. Each cantilever is 340. Then you have each 640-foot span on either side. The 2 deck trusses together, east and west, total about 4,800 feet, which is almost a mile. The east trestle leading into the tolls is only about 300 feet, and then the west causeway is 8,000 feet. Now, thanks to Andrew O'Rourke Jr., the Public Information Officer for the Thruway Authority, I have some great archival photos of the actual construction of the bridge, which began on March 16, 1952. This is just a little taste. There are books, there are websites, other sources where you could see more of this, but here we go. We're getting what are called vents, which are the supports under the causeway and the deck trusses into the river. There we have one of our cantilevered sections. We're lifting them up onto the center piers. That's what the 2 cantilevers look like. See how they jut out from their support? And now we're just waiting to drop in the center span to tie it all together. There's the first beam put across, joining the whole bridge. You know what this kind of reminded me of? Remember the Golden Spike when we were in school, the Transcontinental Railroad? The 2 railroads united, and you had people shaking hands in a nice ceremony. Well, that's what we had here. And then that's what the bridge looked like at the end of the day, the completed structure. Now, the bridge was opened to traffic on December 15th, 1955, at a time when people were driving cars that looked kind of like this. The Thruway, of which this Tappan Zee was a critical link, has had a big impact on everyone. It changed the way most of our freight is moved. It's increased our mobility and given us more options in planning or not planning our trips. We can hop in our car whenever we want. It certainly reinforced the auto-dominated nature of the suburbs. By providing an easy link to the New York City side of the Hudson, the Tappan Zee Bridge had a huge impact on Rockland County, much like the impact the railroads had on Westchester a century earlier. Here are the census figures for 1950, 1960, and 1970. First, we'll go through the Westchester County column on the right. These numbers are within a couple percentage points of what the population growth rates were like in New York State as a whole. In the 1950s, you had a 29% increase in population. Remember, this is the height of the baby boom, right? And then from 1960 and 1970, you had an 11% increase. In Rockland County, on the other hand, look at these numbers. In the 1950s, instead of a 29% increase, you had a 53% increase. And again, the bridge was only open for about 4 of those 10 years. So the first full decade it was open, from 1960 and 1970, while Westchester grew by 11%, and the whole state grew by somewhere around that amount, Rockland grew by 68%. Yeah, that rate of increase, the 68% between 1960 and 1970, is awfully close to the 70% increase in population in Westchester during the 1850s, the first full decade when the main railroad lines were first operational. With the bridge and the rising population, Rockland became a modern suburb based on automobiles and roads. Single-family homes proliferated. Families with young children were everywhere. Schools were expanding. And corporations were locating next to the Thruway. As the processes of suburbanization, the population increases, the neighborhoods of single-family homes, the proliferation of families with young children, the relocation of corporations solidified, the bridge became a regional workhorse, and its load just kept growing. In 1956, the bridge carried 18,000 vehicles every day. 50 years later, it carried well over 100,000. As you could see, the first full year, roughly 18,000 vehicles a day. By 1990, it was up to 100,000. In 2010, we're talking about 134,000 daily, which is an average. On average weekdays, it jumps to 140,000, and on peak days, it can go as high as 170,000. All of that use on a span built on a budget was bound to take its toll on the bridge, please excuse the pun. The design standard for the key parts of this bridge were only 50 years. And when you look at the bridge, it was not built to last. Remember, we had a lot to do during that period. We were just coming out of World War II. We had the Korean War going on at this point, which did not create the same demand for resources that World War II did, but it still created a large demand for resources that were then taken out of the civilian sector. And this was a bridge crossing a very wide area. So it's kind of like a piece of taffy. You had to keep stretching it thinner and stretching it thinner and stretching it thinner, and this is the result. Let's first talk about the deck. That's the part we think about the most. To carry the load that it's come to carry, you'd want a deck of about 9 to 10 inches thick. The deck on the Tappan Zee was built to specifications of 6 inches. So clearly you're going to have problems with the deck sooner rather than later. The drainage system was very primitive. You had open drains, which could cause problems with roadway conditions when the weather was bad. When the water did manage to drip off the roadway, there was no protection for the steel members underneath. Now, you have to remember the water that's coming through, there's a lot of salt water because of the road salts used to keep the roadway from being slippery. Salt is a corrosive on metal. So those metal sections are going to start rotting out on you sooner rather than later as well. The West Causeway leading to Rockland County was actually set not on steel piles like you had going through the floating caissons. They were set on piles of wood, timber piles, untreated timber piles. That's become a real problem today because at the point this bridge was built, there was a lot of industrial pollution in the river and a lot of the native species had died back or died out entirely. Well, now that we have a cleaner Hudson River, the shipworm has come back. The shipworm is actually not a worm, it's a kind of clam. It bores into submerged wood. So there are concerns about the long-term health of the causeway because with the return of the shipworm, they may start eating the timber pilings under that. Now, you also have other problems that you may not know about. There's really no good way to access the rods supporting the caissons. You have 200 deck joints as well, which you can see. Sorry about that. I knew I was going to have trouble with the technology sooner or later. Every bridge is built of a number of spans. There are 200 spans on the Tappan Zee, and each two are connected by deck joints. And these deck joints obviously also create a potential for trouble. I don't know if there's anyone here from my district. We have a bridge that's falling apart called the Ashford Avenue Bridge. And we think the big problem there was that when the deck joints started to malfunction, they created pressure on the stress on the concrete, and that made the concrete start to crumble. So the more deck joints you have, the more potential for trouble, and we have an awful lot of deck joints on this bridge. Another problem, which is more theoretical, is called a lack of redundancy. When you think of redundancy, think of the emergency brake on your car. You want a backup system in place in case something goes wrong. If you park your car and you stop it and your main brake system disengages, you want something to keep you from rolling down the hill. With something like bridges, where you're dealing with hundreds of thousands of people a day, for safety reasons, redundancy is a good thing to make sure if one support fails, there's a backup support. There is what in our postmodern minds is considered a shocking lack of redundancy on the Tappan Zee. The reason why is this was a very optimistic time. We were convinced we could conquer the world, we could do anything. We were about to send men to the moon, although we didn't know it at the time. The engineers thought that as long as they had computer technology to check their math, there wouldn't be any miscalculations and you wouldn't need redundancy. But the one thing they didn't think about was the standards of repair and whether the infrastructure was going to be kept up. And if you don't maintain your infrastructure, well, you start having problems. So, compounding our problems on this level is the fact that the bridge carries more traffic than was planned. The planned capacity was 100,000 vehicles, which we hit in 1990, but currently, as you know, we go up to 170,000 per day on peak days. The result is congestion. You don't see too much of the bridge here, do you? It's all cars. Another result is sprawl. Does anyone recognize what this is? That's right, there's Lord and Taylor. Right, ladies? This is, in many people's minds, the apotheosis of sprawl. But when you drive along the Thruway behind copses of trees, you see all kinds of corporate headquarters, shopping centers. There are many more malls along this stretch of road as well. And what that does is it compounds people's dependence on cars, because you can't walk to this. And when you let your mass transit systems atrophy, when you let the system of railroads that existed on the Rockland County side of the river atrophy, everybody is tied to their cars. Now, if you're operating over capacity, whether you're a bridge or whether you're a person, it's not good for you. It's not good for the bridge, and we've seen that that bridge was already designed to cause trouble. And this is obviously going to cause it even more trouble. But this is hard on people too. When you're stuck in congested traffic, you lose time, you get stressed out. You're not exercising, so your cardiovascular system goes. There's more and more pollution you're breathing in, which isn't good for your lungs. And it adds more stress in that your form of transportation becomes less and less reliable. Remember, if you're sitting in traffic like this, it's hard to predict. When you take a train out of Grand Central, you're pretty sure when you take the 1120, you're going to make it to Hastings at 11:57, and you're going to make it to Dobbs Ferry at noon, unless a really extraordinary event happens. When you get in your car, when you're coming back from a holiday weekend, or you're leaving for a holiday weekend on a Friday afternoon in the summer, you don't know how long it's going to take you to get to the Catskills or how long it's going to take to get you from the Catskills. It depends on how bad the traffic is. This makes it hard for people to plan their lives. And as I said, there are also physical and psychological consequences to that as well. Now, of course, with all of the stress on the bridge as well as on us, structural problems begin to mount. The one the one big problem that everybody was able to see in the last decade was the punch-through. Punch-throughs are holes through the deck of a bridge, showing the land or water below. Now, the Tappan Zee Bridge has experienced, you don't want to think about all the punch-throughs. In the years 2000, 2003, and 2004, I won't tell you why we don't have figures for the 2001 and 2002, but for those 3 years, we had an average of 56 punch-throughs on that bridge. Now, this is really fun. First, we'll look up here. This is a punch-through on the Ambassador Bridge in Windsor, Ontario. It was the best picture of a punch-through that we could find, and this is a great one. Instead of looking from the top down the way you would if you're driving your car and said, uh-oh, there's the Hudson River, this shows it from the bottom up, and you could see the building, the red of the building peeking through the hole here. Now underneath, this is even scarier, folks. This is a graph from actually a revised draft of an engineering report that had been done by a private firm for the Thruway Authority. It plots out lane by lane, 1 through 7, the Tappan Zee is 7 lanes, and span by 10 spans by 10 spans, where the punch-throughs occurred in the years 2002 through 2004. Each circle represents a single punch-through. Now remember, these are holes that you look down and you've got the deck you're standing on, then you've got the river. These circles are different sizes because each size represents a different size punch-through. The ones that really give me the willies are like this one. Over a punch-through over 100 square feet. If you think about the length and width of a car, that's a very scary punch-through. Now, in the 18 months before another 2009 engineering assessment, in 18 months, there were 45 punch-throughs. So I guess you could say they leveled off, but 45 punch-throughs in 18 months on a bridge, the importance of the Tappan Zee, and on a bridge that carries you is a real problem. For obvious reasons, the bridge needed major rehab work. In the last 6 years, we have spent close to $280 million just to replace the worst parts of the deck of the bridge to prevent more punch-throughs. From 1970 to 2010, we've spent over $1.1 billion on fixing the current bridge, and it's not getting that much better. The New York State Department of Transportation rates bridges on a 1 to 7 scale, 7 being brand new and 1 structurally failed. The worst county-owned bridge, the Ashford Avenue Bridge, is at 3.65. The Tappan Zee, with all of this work, the $280 million of deck work and the $1.1 billion of general work, is hovering around 3.7. This is an improvement because 10 years ago it actually dropped below a 3. It was a 2.9. But all of this, think about all the money we've spent, and the bridge is still not in great shape. And the potential for major problems to supports like the timber piles and the rods under the caissons is still there and hasn't been addressed and probably can't be addressed with current technology. So something clearly has to be done with the Tappan Zee. The first question was, do you rehab it or replace it? The environmental impact statements drew up different scenarios, different plans for either rehabbing the bridge or rebuilding the bridge. The dollar estimates in 2009 for the rehab options range from $3.4 to $6.3 billion. that's a lot just to fix something, but as you saw, this is a big bridge with a lot of problems. The rebuild options at that point were 5.2 to 6.6 billion. Because of a new form of letting out contracts called design build, which means a group of companies are responsible for the price they say it's going to cost to build something they themselves designed. In the old system, somebody designed something, then somebody else came to build it and then they'd say, I'm sorry, I have to charge you more. I did my best, but you gave me these drawings and it's just too expensive to build them. With design build, you are responsible for building what you create. That brings down the prices somewhat. It's been tried in other parts of the world. So the design build contract for a replacement is $3.14 billion. Compare it to these numbers. Rebuilding definitely makes more sense financially. But we also have other advantages to a new bridge. First, it'll be safer for traffic. The old Tappan Zee doesn't have shoulders. You know what happens with roads when you don't have shoulders? You end up creating congestion when there are accidents, and you end up creating more accidents. So we'll have shoulders. The lanes are wider to meet current safety specifications. There will be better drainage, so it'll be safer to cross in bad weather. The grade will be gentler. The current Tappan Zee bridge can go as high as a 3% grade. Cars don't have trouble doing that as a whole, but trucks, on the other hand, do. So sometimes you're crossing the bridge and all of a sudden things slow down and you discover, if you manage to pass or you're able to see when things turn around the bend, that there's a truck that's held everything up. Trucks are carrying heavy loads. They're not meant to go on inclines that steep that quickly. So this is a gentler grade, so the trucks won't slow down as much, and that'll help keep traffic moving too. We'll actually have fixes that will make this bridge safer in earthquakes and in windstorms. When the Tappan Zee was built, no one was really thinking about our part of the world as an earthquake zone. But of course, sooner or later, when you're on the Earth's crust, which is cracking because things move underneath, every place in the world is going to be an earthquake zone sooner or later. And it turns out there's a fault line underneath the bridge. By the way, there's also a fault line underneath the Indian Point nuclear power plant, but that's a different lecture. They are concerned about putting in structural redundancies to make the bridge more resilient to extreme events like earthquakes, windstorms, and acts of terrorism. They are building it to last. They are promising no major repairs for 100 years, which, when you factor how much money we're spending on fixing what we've got, is certainly a big deal. I don't know what the terms of the contract are like to hold them to this, but as far as the actual construction of the bridge, with design build in place, we're not going to see the huge kinds of overruns we've seen on other major projects. We also have room for pedestrians and bicycle traffic on this bridge, which means it'll be a recreational resource. I'm not sure people will walk back and forth across a 3-mile bridge for basic transportation, but certainly people could do it by bicycle, and it can become a nice scenic recreational vista. The bridge is also made ready for mass transit. Now let's look at some artist renderings. This is your bike and pedestrian lanes. It kind of looks like a latter-day version of the Brooklyn Bridge. Many of you walked across that. There are viewing platforms. One thing we are going to have that we don't have on the old bridge is we're going to have what are called suicide screens. I don't remember the bookend years, but there is a 10-year period in the last 20 when there were more than 25 suicides off the Tappan Zee Bridge. This kind of thing will help and will certainly help prevent the kind of impulse attempts on people's lives that are the kinds of suicides where you have people throwing themselves off bridges. Here are the lanes. We're going to have a total of 8 lanes. We now have 7. We have 3 eastbound, we have 3 westbound, and then we have 1 in the middle that you have the moving barrier, so during rush hour, that 4th lane is a swing lane that can go either way. We are going to have 4 permanent lanes in either direction. We're also, here are our breakdown and our breakdown/shoulder lanes. We can fit something as heavy as commuter rail by building underneath these piers here. So that's where the mass transit ready part comes in. And as you can see, there's been a little bit of controversy on my staff about this, but the old bridge looked very industrial, right? It looked very industrial revolution, very 1800s, very early 1900s. This is a postmodern bridge. It's a more graceful looking bridge. And with the light colors, you can see it doesn't quite blend into the atmosphere, but it certainly lives a little bit more harmoniously with it. Now, we can keep building bridges, but beyond a certain point, we've got to talk about how we've structured our civilization at this point. With everything centered on cars, you end up with a lot of traffic. You end up with the problems that traffic causes. So, since the year 2000, when the discussion about what to do about the crumbling Tappan Zee Bridge began, people have taken the tack, we need to talk about how to turn this into a better future for the region, and that future should include more mass transit. Now, these are the arguments in favor of mass transit. Call it demography is destiny. On either side of those of us who are middle-aged, there is increased demand for mass transit. Young adults don't like driving as much as we all used to. They don't run out as fast to get their driver's licenses. They delay the purchase of their first cars. They like mass transit. They believe in mass transit, and they want more of it. At the same time, senior citizens who are still able to be mobile and active, but for whom driving is taking more of a toll, either because of failing eyesight or other reasons, they want more mass transit too. There is a study done by Westchester County in the last year and a half, of senior citizens in the county. It turned out that there were people who thought for sure it was going to be property taxes, which are a concern. But it turned out that the senior citizens themselves labeled the #1 short-term and the #1 long-term concern, transportation and mobility. So senior citizens need the mass transit too. We have a market for it. And the other thing to keep in mind is, especially with this generation of young adults, if they want to move into places that have mass transit and we don't have it, what's that going to do to our property values? What's that going to do to the continued vibrancy of our communities? This is a way of planning for our future. Second thing is mass transit is healthier and better for the environment. You have less automobile pollution going into the air. So mass transit is also a public health imperative. The other thing to keep in mind is we cannot build our way out of traffic congestion forever. But there is a forensic engineer named Robert Hintersteiner who estimated through his methodology that we would need to handle 2040 traffic, which in the life of a bridge isn't far into the future, a 12-lane Tappan Zee bridge. And his view is if you want a 12-lane bridge in place, if you need a 12-lane bridge in 2040, you better build a 12-lane bridge in 2020. Where are we going to put those 12 lanes? Are we going to stack it up and make a huge visual eyesore that way? Are we going to expand it horizontally and blow out half of Nyack and half of Tarrytown? We have to think about more space-efficient ways of moving people, and that's one of the things that mass transit does for you. Now, there's been discussion about different types of mass transit. Railroads have done us well here in Westchester, and there's a lot of interest in building an east-west commuter rail line, just like the Harlem, the Hudson, and the New Haven line, that would cross the Tappan Zee, run from, I think they're talking about Hilburn at that point, in the far reaches of Rockland, all the way over to Port Chester and Westchester, and would connect with the New Haven line. The problem with that, however, is that railroads are very, very expensive. They eat up an awful lot of real estate in highly developed areas. So whose houses, whose neighborhoods, whose businesses are you going to demolish to put in the railroad? Big problem with the railroad, which adds to the expense and adds to the land grab, is remember how I was talking about grades before and how a 3% grade can cause a problem for a truck, but a truck can do it. In order to build a Metro-North type railroad, you cannot have anything greater than a 2% grade to run the train safely. So what that means in a hilly area like Rockland County, you're building an awful lot of tunnels. Conditions in which you build tunnels and tunnel building techniques vary, but the general rule of thumb is every mile of tunnel will cost you $500 million. $500 million. When you think about all the tunneling you would have to do through Rockland, we are talking about something that where financing the bridge is a pretty close run thing, even though we absolutely positively need it. Funding a commuter rail just is not realistic at this point. But we can do something called bus rapid transit. The examples in these photos are from Bogota, Colombia, and Ottawa, Canada. This is a less expensive option that's gentler on the existing topography. You don't have to tunnel and do 2% grades for buses. And it's also gentler on existing homes and businesses because you don't have to condemn as much property. There is currently, in this country, a 9-mile BRT called the Health Line, again, encouraging people to get out of their cars and do some walking, in Cleveland, Ohio. And there are variations on bus rapid transit being planned in the San Francisco, San Jose metropolitan area in California, in Pittsburgh, Pennsylvania, and in the area around Richmond, Virginia. Now, another nice thing about bus rapid transit is it's much more flexible than trains. Trains, you have fixed engineering requirements. BRT, you can build a variation to your specifications, to your budget, and to your existing land use conditions. You could do something like this, which is essentially, it's like kind of like a train line run with buses. You could add lanes to an existing highway, which was done here in Bogota. You could even run a more compromised form of BRT just by using things on existing lanes like transit signal priority. The bus will have a sensor, and as the bus approaches a red light, the light will turn green for a bus, which means that the bus would be traveling the same lanes as cars, but the bus would still be able to get where it's going more quickly, which would hopefully increase the ridership because being on the bus would take less time than being in the car. You can also build BRT if you've got the space, but you just want to test it out. You don't have to build curbing. You can do it with gallons of paint. There's been a lot of that done at this point in various parts of Manhattan. So this is something that you can start with and then add to over time to meet the individual needs in a particular region. Now, of course, we need bus rapid transit, or we need trains, and we need a long corridor. going through both counties, because you can't just have a mass transit system on the bridge and drop people off and maroon them on either end. You need to give them destinations where they want to go. And as I said, according to the most recent thinking, the Tappan Zee would be at the center of a bus rapid transit system that would run from Suffern in Rockland County. They brought it in from Hilburton. It's going to be Suffern, and then running over to Portchester. There will be a limited number of stops. It won't be your typical bus that stops every 2 blocks. But it will connect the BRT to commuter rail lines and to big local trunk bus lines. So you may have half a dozen stops in Rockland and maybe another 6 or 8 stops in Westchester. It could either run on the right-of-way for 287, or we can use it on local roads. It has been discussion on the Rockland side of putting part of the BRT on Route 59. The route, after all the years of looking at maps I've seen, that probably makes sense in Westchester, is to alternate between Route 119 and 287. Probably take 119 right off the bridge, the entrance by exit 1 of 287 go up on the highway, bypass have exits on Elmsford on an elevated system that runs with the highway, and then drop it back down onto 119 once you get to exit 5, which is just before the county center. Anyway, this is still all under discussion and under consideration, but these are the kinds of things that people have been thinking about for a number of years, and these are what we're going to have to think about as we join in and help make the choices for our region. The big conundrum as we move forward is how much mass transit and where. If the history of the Tappan Zee Bridge is a guide, we need to consider more than what works in our communities as currently configured. We also have to think about how an effective transit system will change our communities and to plan for those changes now. We also have to make sure that enough people can reach mass transit easily, so that way we have a market for the system. And of course, that presents more problems the more and more spread out your housing is. You can't run a bus every 10 minutes in front of the 3-acre properties in Pound Ridge, for example. It's just not financially feasible. So we have to think about what existing housing we can reach, and then think about the housing of the future. Now, I heard a groan when this screen came up, and we could talk about that a little bit. But transit-oriented development is going to be a way to help provide the market keep the market stabilized for a mass transit system, and to keep our communities more vibrant. Now, we don't want to turn all of our open space into this, do we? No. We probably don't even want to turn our neighborhoods with single-family homes into this. But if we, say, have a transit hub near the intersection of 287 and 9A in Elmsford, maybe not something quite this big, but maybe something along these principles would be a useful idea. What it is a collection near a transit hub of higher density housing, apartment buildings, shopping, restaurants, amusements, within an easy walk of wherever the mass transit is. So this one, you've got your train. You got your train here. I assume this is the station here. So you see, you've got a build out of maybe 3 or 4 blocks, which for the vast majority of people, they'd be willing, if they made the decision that they wanted to live a lifestyle like this, they'd be able to walk that on a daily basis, no problem. So what this does, now think about transit-oriented development. We've always had transit-oriented development. Anyone who knows anything about the history of New York City, the subway lines started coming up and the L started coming up through northern Manhattan, while that was still pretty much meadows and farmland and spread out houses. But if you build it, they will come. the price of real estate, largely by speculators with inside information, shot up when people found out where the subway stops were going to be, because they knew that those areas were going to turn into, well, perhaps a grittier New York City version of something like this. And they knew their property values were going to soar as a result. So so as I said, this has always happened, but now we're talking about how to plan for it in advance. So it's done as gracefully as possible, so it helps the people who will move into there the most, and it becomes as good a neighbor to the rest of the communities as possible. Now, I was involved in the Tappan Zee Bridge working groups from 2007 to 2010. There were Department of Transportation consultants who came into local communities where the BRT hubs were being discussed to talk to them about some of the possibilities. I went to one of these presentations. That one happened to be in Elmsford. And they were one of a number of communities that wanted to see what was coming, what the future could potentially be like, and to start thinking about how they might fit into it. Now, if you want a big lawn for your kids to play on, transit-oriented development isn't going to be for you. But for young adults who might want a little more space than they can get in the city, or who want to grow roots in a community before they have children and move to that big single-family house, or for families who like suburban schools and suburban communities, but who cannot afford a single-family home, or for empty nesters who don't want to take care of the big house and the big yard, or for aging residents who would like to stay close to the communities they've lived in for decades, we don't have enough suitable apartment or townhouse living now. There is a demand for this type of housing. As I said, there is a growing demand for mass transit as well. So if we can concentrate this kind of development in mass transit corridors, we can develop thriving mass transit systems along with thriving diverse communities. And if we center all of the concentrated development near the mass transit, which is generally in well-trafficked areas now, we can save our open spaces. It'll be easier for us to save our open spaces as well. So there's really potential in this kind of concept. So the Tappan Zee Bridge was built, the original bridge, was built to serve the kind of communities our region had been building for well over a century, the suburb. And its existence created even more suburbs. Because it was built on the cheap, we need to replace it. And since we need to confront the disadvantages associated with automobile-centric suburbs at the same time, a mass transit system centered on the bridge, doing both at the same time, will generate the mix of options that our people need, and that will help preserve our environment in the long run.